Listen students, in this part of the video about vectors, we are going to learn about the resolution of the vectors and as well as parallelogram law of vector addition. If you understand the resolution of the vectors in a proper way, it might be easier to solve the problems in coming units of physics like the force, work power energy, and as well as collisions. That is, totally the mechanics can be solved very easily if you understand the resolution of the vectors in a proper way. Actually, this video is meant for the NEET aspirants who are struggling with the physics somewhat, and also the students who are going to join the first year of intermediate. Let's start with resolution of vectors. What is the resolution? You have to understand. What is the resolution? You have to understand first. Resolution is nothing but dividing a vector into two rectangular components. Not only two, you can divide a vector more than two rectangular components. Here it can be understandable very easily. Let's say it's a two-dimensional plane. We are resoluting the vectors in two dimensions right now. Is the origin, say it is x-axis, and it has y. Here we are learning about resolution. I already told you what is the resolution is. Resolution is nothing but dividing a vector into two or more rectangular components. Here it is a two-dimensional plane. Let's locate a vector. It is the origin. I am locating a point here. Say it is the point A, and I am joining the origin with that point. Let's say it is a position vector. Okay. Here this vector is making an angle of theta with the x-axis. Now I am dropping a normal from A to the x-axis, and as well as I am dropping a normal from A to y-axis. If it is a theta, it might be the theta. Okay. Let's this vector is A, vector A. If you watch this carefully, you will find a triangle. Say it is OAB and call it SC. If you watch the triangle OAC, see in triangle OAB, you know the trigonometric ratios. You learn that sine theta is equal to opposite upon hypotenuse. Opposite upon hypotenuse, and cos theta is equal to adjacent upon hypotenuse. Okay. Here we are writing the value of the sine theta right now. Sine theta can also be written as AB upon OA. Okay. It can also be written as AB by vector A. Let's say it's a vector A. I am writing its component along y-axis as AY. Okay. Then AB can also be written as AY upon A. From this equation, we can write AY is equal to A sine theta. It is the vertical component. It is the vertical component of vector A bar. Similarly, if you take the cos theta can be written as what I wrote there, adjacent by hypotenuse. If you see the triangle, the adjacent is OB by OA. Here, if the vertical component is AY along the y-axis, then automatically we can write it as AX. OB can be written as AX by A. It gives us what AX is equal to A cos theta. Here AY is the vertical component. AY is the vertical component of vector A, where AX is equal to horizontal component of vector A. Here, dividing a vector into two rectangular components is known as resolution of vectors. I hope you understood. Here, it's a very easy process. Dividing, but we divided this vector A bar along the horizontal and as well as the vertical. That is, X is equal to A cos theta and AY is equal to A sin theta. If you say the unit vectors along the x-axis is equal to I cap and y-axis is j cap, then these terms can be written as Ax is equal to A cos theta I cap and AY is equal to A sin theta j cap. Just imagine it has been divided into two, more than two, that means three components. Then immediately we'll get the three components as what A bar is equal to Ax I cap plus AY j cap plus AZ k cap. Students, in the previous video I explained how to add the vectors. Vectors can be added by tail to tail and as well as the head to head, I told. Okay, and also I said vector addition is commutative. Here we are going to learn about one method of addition of the vectors. It is known as the parallelogram law of vector addition. Listen this concept carefully. My advice is see the video till the end. Here we are going to learn about parallelogram law of vector addition. Okay. Now say we are taking two vectors. Let's say vector and we have one more vector. Is the second vector. Okay. Let's say this vector is P bar and it is Q bar. We have to add these two vectors. Before adding that, we have to know a simple concept, that is transpose of the vectors. For example, you say is a vector A bar and we have one more vector, it is B bar. Okay, what's the transposing of the vectors? It's very simple. Changing the place of the vector. Changing the place of the vector. changing the position of the vector from one place to another without changing its magnitude and direction is known as the transposing of the vector. Changing the position of the vector from one point to another without changing the direction and as well as the magnitude. That means what? I am bringing this vector and I am keeping the vector here. I kept the same vector and it has the same magnitude as b bar and the direction is same. In the same way, if you take this vector and keep here, I transpose the vector from here to here. Okay, nothing is changed, the magnitude remains constant and as well as the direction. This process is known as what? Transposing of the vectors. Here I am doing the same thing. I am taking this vector and I am keeping it here. I am moving this vector from here to here and I am adding their tails. Tail se tail mila. Okay, we are adding the tails of the vectors. It is p bar and it is the q bar. And what I am doing, it is the angle between the two vectors. Okay, here I am transposing this. I am bringing the vector to this point. Okay, obviously it is q bar. Then I am transposing this and keeping here. I kept it here and I got a parallelogram. Okay, it's a p bar and obviously it is p bar, is a q bar and it is a q bar. Now here if I extend this, it might be equal to theta. Okay, here when two vectors are added, we have to take the angle as the smallest one. It's not the angle between the two vectors, but it is. Remember, when the two vectors have been added, we have to take the smallest angle between the two. It is the extension of this vector, this angle. We have to consider the angle between the vectors, but not this. Okay. Now say, I am joining the heads and as well as the tails. Okay, and I got a vector. Say this vector is r bar, and say the parallelogram as OA B C. OA B C is a parallelogram. Now see what I am doing is the q bar. I am dropping a normal from this point onto this. Let's say it is D. Okay, it's a vector p bar and it is q bar and it is r bar. Okay, if you watch it carefully, you will get a right angle triangle there, that is OBD. And you know that according to the Pythagoras principle, the square of the hypotenuse must be equal to square of the adjacent plus square of the opposite. I am using the same here. In triangle, which triangle it is? It is a triangle ODB. Okay. According to the Pythagoras principle, what I have to write? OB squared is OB squared is equal to OD squared plus DB squared. You are aware of this. From first class you are learning about the Pythagoras principle here. But if you watch it carefully, you will find OD is equal to OC plus CD. Okay, and we don't know the value of the CD and as well as the BD, and we have to find it we have to find it indirectly. OD can be written as OC is equal to P plus CD. Now we are using the process of resolution of the vector. Resoluting CB, that is Q bar, into rectangular components. What we get is the Q, and I already told you it is cos theta. That means it is Q cos theta, and obviously it is a Q cos theta, and it is equal to Q sin theta. I hope you understood. In other topic only I explained that. Okay, CD is equal to Q cos theta, and DB is equal to Q sin theta. Okay, I'm putting these values in this equation. OB squared is equal to OD squared, means what? P plus CD whole square plus DB squared. Obviously it is Q square sin square theta. By putting all the values here, it is P plus CD. We got CD as Q cos theta. Q cos theta whole square plus Q square sin square theta. And it can also be written as P square plus Q square cos square theta plus 2PQ cos theta, because it is in A plus B whole square form, plus Q square sin square theta. And it can also be written as P square plus 2PQ cos theta plus Q square of sin square theta plus cos square theta. As you know that sin square theta plus cos square theta is equal to 1. Then OB is R squared. R squared or the resultant R is equal to under root of P squared plus Q squared plus 2PQ cos theta. It is the desired relation. By using this relation, you can find out the resultant of the two vectors when they are inclined with certain angle. Then after we will find the angle between the first vector and the resultant. Let's say it is alpha. We have to find out the alpha. That means I am taking the tangent. Tan alpha can be written as, tan is what? Opposite by adjacent. Tan theta is equal to opposite by adjacent. I am writing the value of the opposite. It is Q sin theta upon adjacent P plus Q cos theta, or alpha is equal to tan inverse Q sin theta upon P plus Q cos theta. It is the angle between the first vector P bar and as well as the resultant. We derive the expression R is equal to P square plus Q square plus 2PQ cos theta. Do remember that. In vector algebra, 2 plus 3 is not equal to 5 in all cases. If you go with the algebra what you learnt from the first class, always we write 2 plus 3 is equal to 5. But here we can't say 2 plus 3 is always equal to 5. Here the magnitude, that means sum of the two, depends upon the angle of inclination. Okay, I hope you understood this class. If you like the video, please subscribe my channel, and if you deserve, then give a like.